So I'm going to be talking about the Quantum Open Source Foundation, and the goal of this talk is to first walk you through the story behind QOSF. How did we get to this point? What is QOSF about? And what's the future vision in terms of like missions and goals? And this talk is also going to be a lot about how you could potentially get involved, because none of this could be done entirely by Tomasz and myself and the core team of QOSF that I'll show you in a bit. So throughout this talk, I'm going to have this little small request duck, which is going to pop up at random places, and it's going to like just ask you about certain skill sets or things that you might be interested in. And if anyone is interested in helping, just drop us a message on the Slack channel, which you can join through this link, or send us an email. So first of all, what's the story behind the Quantum Open Source Foundation? It basically all started with a small GitHub project that back in the day I was hosting on my own GitHub, and by now it's like on the QOSF GitHub, and it's basically a list of all, well, we're trying it to be all, but there's always some missing, open source quantum projects. So we broke it down into different categories like full stack libraries, simulators, compilers. There's a category for quantum fun where we have quantum games and other things. And each category is broken down into programming languages. So the goal is that if someone wants to get into the space and maybe like, I don't know, start a project on a quantum simulator, and they happen to be, or they might want to join a project and they're very comfortable in Common Lisp, they can go to the category for quantum simulators and then look for Common Lisp subheader and actually find all the projects that are implemented in that particular programming language. Then, like Tomasz and myself had several publications in the quantum computing space, and we worked with all of the various hardware players, D-Wave, IBM, Xanadu, Rigetti. And at some point, this journal PLOS ONE, that is very focused on open access science, approached us and asked us to write a review paper on the open source landscape in quantum computing. And we were pretty excited about this, and we joined forces with Peter, and we started working on this project where the goal was to kind of look into all the various repos and also dive into the literature on traditional open source software engineering and figure out, okay, what are best practices that the community should follow, and do most of the projects that are out there actually adhere to these best practices? For me, there was one particular learning that I found very surprising. There's a thing called Brooks' Law, and Brooks' Law says that adding human resources to a late software project will make it later. And for the people that have worked in software companies, you might be able to relate to that. And it has to do with this law of diminishing returns, where adding more bodies and resources to a project initially increases productivity. At some point you will start plateauing, and then adding more people, you actually decrease productivity because the communication overhead just gets too big. What I found interesting is that if you look into open source projects, and that's independent of the work that we did in the quantum computing spaces out of this other paper, they actually found out that adding contributors to open source projects always leads to higher productivity, more commits, more codes, and more code and more features. So I think that's a pretty exciting finding, that like the way to developing software open source actually makes sense. One of the problems though was that we realized that this review paper is going to get outdated quite quickly because we can't really update it. We could update the archive version of it, but we can't really update the version that was published in PLOS ONE. And that's why we started a website. And we hosted this evaluation and the results of the evaluation on the website of the Quantum Open Source Foundation. So that was kind of like the first thing that we did as part of QOSF. And the response was overwhelming, and as part of that we like started FOSDEM, the quantum computing track, in 2019, and since then we've kind of like been running various events and growing the idea of the foundation, and also kind of like adding more things to it. And we have quite a big vision, I would say, for the future, but we need help to actually get there. So that's how the core team looks like right now. Mikhail just recently joined, and he's working on a new program that I will be introducing in a bit. And we're also working on building out an advisory board. So right now that's Will and Josh, and we're looking to add more people in the near future. And the goal here is to basically get advice on the various aspects, and that, like, I will be talking about that in just a second, but basically to kind of get high-level advice and guidance on various topics that QOSF wants to work on. But at that point, I would like to point out that without Peter, we would not be here today. We would have not had a quantum computing track at FOSDEM 2019. We would not have it this year, because he was like one of the main driving forces behind the creation of QOSF. But unfortunately, he can't be here today because end of last year, he embarked on a mountaineering journey in the Himalayas, and unfortunately got hit by an avalanche and never got back. So I just wanted to have us all appreciate kind of what Peter did for the community and what he did for QOSF, and yeah, just honor him for that. So what is QOSF actually about? QOSF is about supporting the development and standardization of open tools for quantum computing. So that's pretty generic and wide, and we want to keep it that way because we want to be able to kind of adapt as things develop. And ultimately, it's a community effort between industry and academia. And when I say industry, I mean the quantum computing industry, but also just the traditional software engineering industry. So on our website, we have a manifesto, and there's like 6 items that we want to focus on. And yesterday, when I was looking back at them and I was asking myself, okay, how many items does FOSDEM actually kind of tick off? It ticks off 4, where we have things like foster collaboration between the hardware and software community, incentivize and support the distribution of free and open information regarding advances, which is what the goal of today was, to kind of like showcase some of the new projects, some of the new updates to existing projects, and to organize free and open conferences and generally events that kind of increase the audience and the community for quantum computing. On top of that, we have that we want to provide financial funding, which we have not gotten to yet because we haven't really focused on getting funding for QOSF that much, and providing a forum where people can exchange ideas. And that's the whole point of this Slack channel that we're currently like building up, and which is supposed to be a point where you can connect with people that are working on these projects, that are quantum physicists, or people that are excited and interested in like helping out on existing projects. So in terms of the future, missions and goals, we basically have kind of like defined 3 pillars that we want to focus on. We have a pillar that is about pushing the boundaries, spreading the knowledge, leveling the playing field, and a biannual QOSF prize. And I'll talk a bit more detail about each one of these pillars and what we mean with that. So first of all, pushing the boundaries is supposed to bring together the quantum community and advance the solution of outstanding issues and problems. So what I mean by that is to basically have a list of open, uncracked problems in the quantum computing software space. The idea is that young researchers can come to this list, get inspired, pick up one of these challenges and work on it, and potentially also like get some links and resources linked to that problem that was compiled by other people in the space. So for example, like one of the things that there's a shortage of is compilers. Without me saying that, you might not know that, and you might find it out by like going to that GitHub list that I mentioned earlier, and you will see that there's relatively few projects there, but there might be like more hidden uncracked problems that you wouldn't be aware of unless you like spend quite a lot of time kind of diving into the field. So the idea is to kind of like create a quick entry point. And that's the first time that this little duck pops up, because if you know any challenges, if you have any challenges as part of your project or that you have encountered as part of your academic career, please let us know so we can get started building this list. The second pillar is spreading the knowledge. So this one is very much about outreach and education. And the goal here, or like one of the things that we're doing, is hackathons and workshops. So we did a workshop together with CERN that I will be talking about in a second, but the goal is also to kind of widen the community by not just doing hackathons and workshops for, I don't know, PhDs in quantum info, but actually for people that are new to the field. So that means hackathons with quantum newbies. I have this particular idea of like doing a workshop with kids, because there's like actually some interactive There's a startup that creates interactive elements for kids that you can kind of like simulate quantum circuits with. And also like kind of focus on like the older population and just kind of like spreading that excitement for quantum computing. And I personally always find it exciting to see people taking like maybe a day, maybe 2 days for them to actually run a program on an actual QPU and also understanding what that program does. So at this point, this always takes quite a lot of money running these events. If you know how and where a software foundation like us could get grants or funding from, please approach us and let us know, especially if you've done it before. And this is a particular example, like we teamed up with CERN, the particle accelerator in Geneva, and we ran a Toronto version of their hackathon at the same time. It's called the Quantum Futures Hackathon, and we had a lot of cool projects that came out of that, including Thomas and Kelly, who made the Block It game that they were presenting earlier today. Another thing on the outreach side is like MOOCs, or massively open online courses. So Peter, as part of the U of T and QSF, had an EDX course that is still accessible. You can check it out on this EDX link. It's about quantum machine learning. It might be a bit dense for beginners, but like once you kind of master the basics of quantum computing, that might be a really interesting course to dive in. And we have the course material hosted on our GitLab. And then I want to point out this paper that is a follow-up paper to the review paper that we wrote. And what they are pointing out is that they're saying we observe a lack of educational resources on quantum computing, which is something that I would disagree with because I find there's quite a lot of resources. And Desiree from Australia, she actually has a list on GitHub that lists all the free and open learning resources on quantum computing, and we're mirroring and co-hosting that list on the QSF website. So if you're in need of some learning resources, go and check that out. There's plenty of material. So I mentioned earlier that like Mikhail joined the core team, and like one thing that he started is the quantum computing mentorship program. So for people that want to get into the space, but they might not feel comfortable, or they, I don't know, feel like they're like too early on, that's a great program. You can basically join and you can work on a quantum computing related project, and you get teamed up with an expert from industry or academia, and you're going to work together for 3 months. So it's mostly going to be you working, but you have regular check-ins with the expert. You can get feedback. They might look into your code and kind of help you implement certain things. And the goal of that is to build a community of quantum enthusiasts and also providing a smooth and guided entry to the community. Because again, in that paper they were pointing out, they did a survey of the community and said that it was very much focused on like people with a PhD in quantum info or computer science. And so we would like to kind of break that up a bit and like bring people in from various backgrounds. So if you're interested in that, I did not get to push that code and deploy it before this talk, but we're going to do it before tomorrow. So the deadline opens up tomorrow and goes till February 14th. So if you're interested, or if you know of people that might be interested, feel free to spread the news. And then we have the idea of a decentralized kind of quantum conference. That was something that Will brought up, the idea that like FOSDEM talks are already recorded and put online, but the idea would be to like not just end it with FOSDEM talks, but also have people record talks like that, where they're kind of like presenting their projects and like showcasing or demoing it throughout the year and publishing that on YouTube. So if you happen to know how to edit videos properly, because I don't, and Tomasz doesn't either, we would love to talk to you and maybe partner up and work on these QCon videos, because I'd like to have them look great. And then lastly, the last pillar is leveling the playing field. So what we mean with that is providing an objective reference point to evaluate both quantum hardware and software. So the idea is building compiler and simulator benchmarks. Like this is an example from the classical domain. You can see like different C++ compilers ranked against each other. The idea is that there's way too many quantum simulators out there right now. And if you would want to work on a project, you would face the decision like, okay, which of these simulators do I use? And that is a difficult question to answer, because it depends on what kind of quantum circuit you're trying to simulate. If it consists only of Clifford gates, you might want to use a different simulator that is particularly optimized for that. If you want to parallelize it on a big AWS instance, or if you want to run it on GPUs, those are all factors that are going to influence which simulator you want to use. And we would ideally like to give you that like opportunity to kind of like look it up and have like some central point where you can see them all ranked against each other in order to make this sort of decision. So ultimately, we would love to build what we call a QoSF gym, where you have certain standardized data sets, like those might be like certain types of circuits, and if you build a compiler, you can test it on this standardized set of quantum circuits, and you can measure the performance against other compilers. So you can think of it as kind of like the standardized data sets that are out there in computer vision or just in traditional machine learning like MNIST. And then again, we would have like some sort of public leaderboard that ranks the various implementations and projects against each other. So again, we have that little duck down here. If you fancy helping us develop this, reach out to us, because like we have limited bandwidth. We all have limited bandwidth. So like if you want to spend a little bit of spare time helping us with this, that would be great. And then lastly, in that pillar falls the open source project evaluation that I was touching upon earlier, that is currently accessible on the QoSF website. And the idea here is to have evaluation results for static analysis, things like code coverage of the various projects, but also kind of a grading scheme for the documentation. And the idea is to encourage best practices and also help newcomers decide which project should I be spending my time on. Like you probably don't want to join a project that, I don't know, it takes 3 months to get back to your pull request or your issues, and might also have shitty documentation. So we want to kind of like enable or like help projects to kind of be aware of their shortcomings and then fix them. So again, here we need help to automate this. Right now it's very manual and painful, and there should be good ways of like scripting this. So if you're interested in helping in that, let us know. And then lastly, we have this thought, and that's a very high level thought. We haven't like fleshed this out fully yet, to like create a biannual QoSF prize for the best or most well-maintained quantum open source project. And we would like to dedicate that to Peter, and we ideally want to pull in some partners, maybe some journals, maybe some companies from the software space, and kind of launch this and get this off the ground. And as I said, we haven't fully fleshed this out. If you have ever done something in this kind of way, that like awarding prizes for software projects or anything related to that, please reach out to us and I don't know, share your insights, because we haven't done it either. So lastly, quick overview of the small requests that we have. Tell us about uncracked challenges related to quantum software. If you know how to get funding as an NGO, especially a software foundation, please reach out. If you know video editing, we'd love to collaborate for the QCon 2020 idea. Tell your friends about the mentorship program or sign up yourself if you're interested. And then we need help developing this QoSF gym for the compiler and simulator benchmarks, as well as automating the project evaluation. And if you have ever awarded prizes for software projects, please reach out. So if you want to get involved, there's a Become a Supporter tab on the website. Basically what that means is that you're going to be put on a mailing list where we send out information like FOSDEM or like hackathon events or anything related to the Quantum Open Source Foundation. Join our Slack channel. And this is the end of my talk, and I invite you to check out our GitHub and GitLab profile and follow us on social media. That's it from me. Thank you.
Any questions?
It's okay.
Thank you. It might be a bit off topic, but I'm just wondering if there is such a thing as in 3D there is the Utah teapot, and in programming there is the hello world that you write when you are a newcomer to a field. Is there such a thing in quantum computing with like a hello world first step that you could like devise? And if not, then would it be desirable or bad idea? Just wondering. It's a question for everyone, I guess.
Yeah, I would probably answer it in a way that there is hello world examples, but they are very specific to the particular hardware that you're looking at. So like, for example, Rigetti has their own hello world example, D-Wave has their own hello world example. There's actually a question on the quantum computing stack exchange at some point, like what's the hello world equivalent for D-Wave? And like I wrote a big answer to it, but like it's really hardware dependent and like even like software dependent depending on which tool or framework you choose. So that's the unfortunate thing.
Anybody else? There's one over there.
One sort of comment and challenge related to the hello world question is there are hello world problems in the quantum computing space, but then there's sort of nothing after that, and then you design your own algorithms. So if you're getting into it, you sort of write the hello world, you go like, okay, I can make a circuit. And then step 2 is, all right, start designing your own quantum algorithms and quantum machine learning. And there's no like, all right, now that you've written the hello world, let's see if we can add 2 + 2 and sort of build up skills from there. And I think that's a stage that might also be missing and might actually be more critical, is that you sort of need a guiding track rather than just a jump from like, I have written this code and it works, to I now have to design my own or implement my own quantum algorithms.
Okay, so if I understood correctly, the concern was that there's no good intermediate kind of level materials. There's a lot at the beginning and maybe a lot at the end, but not, I guess, okay. Good. Any other questions? I guess we have time for one last question. Okay, so let's thank Mark again.